Different types of solutions, video 2.5. So in this video, we're going to talk about sometimes when there's no solutions and sometimes when a system of equations has infinitely many solutions. First, I'm going to show you what these possibilities look like when you're shown on a graph. So look at this system of equations. 2x plus 2y equals 6, 4x minus 6y equals 12. I'm going to start by graphing the first equation, and in order to do that I need to solve for y. And in this video my explanations are going to be longer than anything you would do on the actual test, just to give you some familiarity with how things would look, but to answer the questions you wouldn't do all these steps. So here's my first equation. I'm going to graph it using red. Alright, so I have a y-intercept of 3. My slope is -1. So there's the equation of my first line. Let me take the second equation. Be careful when you're dividing by this negative that you get all your signs correct. So that's going to be positive 2/3. This is -2. So my intercept is -2 up 2/3. And you can see that they intersect right here. And that's going to be the solution. So the solution to this system of equations is 3, 0. So it has one solution. So that's our first possibility, one solution. And what that looks like on the graph is two lines intersecting. Alright, let's look at this system of equations. So this is the same equation as before. I'll take my second equation and solve for y. Alright, now look at that. That's the same equation that I had before. I'll use a different color to show this, but I've got the same y-intercept, the same slope. So if I graph this line, it's going right on top of the other line. What we have here are overlapping lines or the same line. What this means is that this system has infinitely many solutions. That phrase can confuse students. It just means that there are an uncountable amount of solutions. Any point on this line is a solution. Let's look at the third possibility. So this first equation we've graphed twice now. So we know it's going to be y equals -x plus 3 when we solve for y. So I'll just go ahead and graph that. There it is with the -1 slope and the y-intercept of 3. And now let me look at the second equation. So we have 4x plus 4y equals 20. Solving for y. So I know I'm going to have a y-intercept at 5 and a slope of -1. When I go ahead and graph that, I'll show you in blue. What happens is I have a parallel line. These lines are never going to cross because they have the same slope. And so this system has no solutions. Alright, now let's just see what equations look like and what happens when you're solving them algebraically and not with a graph. So if it has one solution, here's what would happen. You're pretty used to this. You've done this before. Let's say I'm solving this system. I'd probably use elimination because the y's are opposite. So you find a value for x. You substitute that in. And so your answer is a point, like this. What happens when you have a system with no solutions and you're trying to solve it algebraically? Well, here I have an example, and I'm going to use elimination. I want to have the x's cancel, so I'm going to multiply the first equation by -2. Here's my first equation. Here's the second equation. The x's cancel, but so do the y's. So I have 0 on this side of the equation, and on this side I get 1. So I have 0 equals 1. That's never true. And if you end up with a statement like that and you didn't make any mistakes, you know that it has no solution. The same thing would happen if you did substitution. You'd end up with a statement that was never true. What about infinitely many solutions? Well, here I have my system. I'm going to use substitution this time around to see what happens. So I'm going to take this and substitute it for y. Distribute. Alright, now some of you might notice I have the same thing on both sides. Others might do this next step until you get 2 equals 2. Either way, here or here, you get a statement that's always true. And if you get a statement that's always true, then you know the system has infinitely many solutions. Alright, now with that in mind, let's look at a few of the questions on the redesigned SAT that have to do with this subject in math. How many solutions, x, y, are there to the system of equations below? And here is my system. So I'll show you how to approach it if you were going to actually just solve it. And then we'll talk about if you're able to just sort of look at the problem and not start to solve. So if I was going to do elimination, I would do -2 times the second equation and you end up with 0 on this side and -1 on this side. So that's never true. So that means that this system has no solutions. So the correct answer choice is 0. Now to save time, some of you might have just looked at this, and what you notice is y times 2 gives you 2y, 3x times 2 gives you 6x. So this is multiplying by 2, but then here, since this isn't a 4, you can kind of tell it's going to have no solutions. Because you have like the same thing on the left, you know, multiplying by 2, but then when you get to the right side, it's not the same factor that you're multiplying it by. So that's another way to try to figure it out. If you did have this, where you're multiplying by the same number each time, then these would be the same line, and then you have more than 2, because the answer would have been infinitely many solutions. In the system of equations above, a and b are constants. If the system has infinitely many solutions, what is the value of a? So basically that means that the two equations are for the same line. And we're missing some information about the constants in here. So we have 3s minus 2t equals some number, negative 15s plus bt. The easiest way for me to think about it is, what am I multiplying by to get from 3 to negative 15? I'm multiplying by -5. So if this is the same line, you want to multiply -2 by -5 to get this constant right here. So -2 times -5 equals 10. So b equals 10, because you want to keep that factor that you're multiplying by the same. So now we have, here's my first equation and your second equation. So how are we going to figure out what a is? Well, if we multiplied by -5 to get from this equation, this one, you can divide by -5 to go back. So -7 divided by -5 will give us the value of a. and it's 1.4.